As you can tell by the title of today's notes, we're going to come full circle and get to something. We're eventually going to show that we have a formula that'll be able to solve any quadratic equation. However, you guys are in Algebra 2 now, specifically accelerated Algebra 2. So rather than just give you something that you can just like regurgitate onto a piece of paper, we're going to actually figure out where it comes from today. Okay? Are you going to be required to know how to show this? No, but you should see it, and you have all of the tools you need to be able to show where this quadratic formula comes from. So I'm going to go through, and today I'm going to show you where this thing comes from. And it has a lot to do with, we're going to base this off of what we did yesterday, which is completing the square. So I want to solve this equation. Now all I have are variables here. I'm going to solve this equation using completing the square. So in order to complete the square, we said we wanted to first, we could start by, say, subtracting off the constant, subtracting off whatever doesn't have an x. So we have this thing, ax squared bx is equal to negative the constant, negative c. And if this isn't 1, we'd like to factor an a out. So we'd like to rewrite this so it's a times the leading coefficient is now 1. What happens if you factor out an a from bx? How would you write that? What's factoring out the same as? What do we divide? We're dividing out. So we're dividing everything by a. So what's bx divided by a?
Bx divided by a.
Bx over a. Or how about if I go like this? Would it be okay if I write it like this?
No, incorrect.
Oh, not 6. Okay. What was the pattern for writing a completed square? What did we do to the middle term? Divided it in half and squared it. So I divided this in half. I need to divide this in half. So I need to divide this in half. So divide it by 2 or multiply it by, say, 1/2. What's b times 1 over a times 2?
2a.
Okay. And what's b over 2a? Like the square. So I want to get a b over 2a.
Wait, this. Where'd the 1/2 come from? Yeah.
How did we find when we completed the square?
Yeah.
What do we have to do to complete the square? How do we figure out what to add?
You divide.
Took whatever's in the middle and divided by 2. So I took what's in the middle and divided by 2 or multiplied it by 1/2. It's the same idea. And then I took that number and squared it to figure out what to put inside. We're completing the square. So I took whatever this is in half and squared it. Half of this is b over 2a, and I squared it. So I get b over 2a squared is what's going to go on the outside. What's going to go on the end. What do I add? So then if I added this on the inside, that means to the left side, that means I added b over 2a squared. Completing the square here, folks, is what we did yesterday. Completing the square. So if I added this to the left side, what did I really add to the left side if I add this inside? A times this. Put it in 2 steps so that maybe it's a little bit more apparent. But I rearranged the equation, factored out a. Then I said I'm going to complete the square on the left side. So I took half of what's in the middle. Half of b over a is b over 2a, and squared it. I said that's what I need to add to inside this parentheses so I can write this as something squared. This is the term. Half of in the middle, squared. Half of b over a is b over 2a squared. And then whatever I put in here on the left, I need to put it on the right. So if I put this inside these parentheses we saw from that homework example, then I'm putting this, not just this, but I'm putting this times whatever was in front. So I'm putting A times this in there. So I'll write it as A times this stuff. Okay. So let's, before we go much farther, let's see if we can't reduce and simplify and see what's going on here. B over 2A squared. That's like squaring the top and squaring the bottom. So what's that give me here? A times B squared over, what, 2 squared is 4. A squared is just A squared. You have an A in the top and an A squared in the bottom. How does that simplify? No A in the top. And how many A's are left on the bottom? Just one of them. So I could reduce this and get, say, B squared over 4A, because I multiply both sides by A. It's a valid move, just with some variables. And this junk is equal to, well, this. This is a perfect square now, because we constructed it to be one. This should be equal to the square root of this plus, plus the square root of this. What's the square root of B over 2A squared? The square root of something squared is just what's inside. And that was multiplied by this A up front. Well, so we're eventually going to need to divide by A. Well, let's write this as just one big fraction. Let's write this under one fraction thing. What's the common denominator on the right? Oh, just a second. So like negative C over 1, excuse me. So then to get this to match with that, we'll multiply top and bottom by the common denominator. So I'll multiply bottom by 4A and the top by 4A. And what's negative C times 4A? Negative 4AC. So we're getting there. We're getting close. We've got A. You've got this x plus b over a, 2a's squared. And that's equal to negative 4ac plus b squared. And it's a common denominator, so we can just put it under 1. We can just throw it all underneath of one fraction. Common denominator, if I add fractions, I can just add them together if they have the same denominator, and just under 1. Add the numerators, leave it under one denominator. Does that sound legal so far?
It does, but it shouldn't be.
It does. It's valid so far.
Well, shouldn't it be 4A plus 4A? So it should be A on the bottom.
Rewrite this as, say, b squared minus 4ac. Because that's what we want it to end up anyways. We know where we're headed. Okay. Before we square root, we got to get rid of this a. So you could divide by a, or maybe even more properly, we'd multiply by its inverse. You could multiply by 1 over a, the same as dividing by a. Multiply by 1 over a. And what does that leave us with? Top times 1. It's the same. What's 4a times a? A squared. We're getting there. What's the next thing you want to do? To get x by itself, what would you do? Square root it? Square root of both sides, and you get x plus b over 2a is equal to square root of this side. Well, we know where we want to head with this, right? You know what the quadratic formula looks like. So we really want a square root of b squared minus 4ac. And that's over, say, the square root of 4a squared. What's the square root of 4a squared? What's the square root of 4? So square root of a squared, a. So this is the same as 2a, plus or minus. X plus b over 2a is equal to plus or minus square root of b squared minus 4ac all over 2a. Square root of 4a squared is 2a.
How come the b squared?
Because there's subtraction in here. So since it's like a big group, you can't just square individual pieces from addition. And to get x by yourself, how about we subtract this b over 2a? So then you end up with x equals minus b over 2a plus or minus square root of discriminant over 2a. And you could write this as one fraction because they have the same denominator as your favorite formula, the whole wide world. X is equal to minus b plus or minus square root b squared minus 4ac all over 2a. These apply for any, this applies for all a's, b's, and c's that are real numbers. This is symbol for can be any real number contained in the real numbers. Any real number this applies to, as long as a is not 0. As long as your leading coefficient's not 0, this applies.
So if A is 0.
If a is 0, then you don't have a quadratic anymore, and the quadratic formula doesn't work.
What are those after the a, b, and c?
The discriminant is a very specific, it's a specific part of the quadratic formula. The discriminant is what's under the square root. And the discriminant is useful because it tells you something about this. It tells you how many places how many solutions this will have. If your discriminant is equal to greater than 0, if the discriminant is greater than 0, then there are 2 solutions. Two real solutions. If the discriminant is equal to 0, then there is 1 real solution. And if the discriminant is less than 0, then you get no real solutions, but you get 2 complex solutions. You'll have answers that involve the I, the imaginary number, if your discriminant's less than 0, because you'll take the square root of a negative number. So in the old days, before we could handle square roots of negative numbers, you would say there were no answers. But now that we can handle complex numbers, we can handle square root of negative numbers, we actually get 2 answers, but they'll be imaginary, they'll be complex, they'll have an imaginary component to them. With that, I don't want to spend a ton more time on this because if once you have the formula and once you can plug stuff into the formula, then I don't want to hold your hand through it. If you can write these in standard form, then it's a matter of plug and chug. So write our equation in standard form. Write your equation in standard form. Identify A, B, and C from standard form. Like A is 1, B is -5, C is -7. And then quadratic formula. The formula's on the front, plug the numbers in, and simplify. You get x is equal to negative b, or opposite of b, opposite of b, plus minus square root of b squared minus 4 times a times c, all over 2a. 5 plus or minus square root of 25 minus negative 28, or plus 28, all over 2. 5 plus minus root 53 over 2. You can simplify this. 5 plus root 53 divided by 2, 5 minus root 53 over 2. Maybe 2 solutions.
I'll do it.